Welcome back to the commonly used Excel charts and functions video series. Today in lesson 9, we will be covering the box plot. So today we'll start off by going over how to make a box plot chart, and then we'll transition into interpreting and reading what the box plot chart tells us. You can see on the left-hand side we have a data set that consists of 3 exam scores for a class. And to make the box plot chart, let's highlight our data labels as well as all of the data itself and go to the Insert tab. I'm going to go to the Statistics Chart option and select the box and whisker choice, and then I'm just going to move the graph up a bit. The first change we'll make to this graph is the chart title, so I'll just remove that place header there, and my title in this case will be 3 exam scores for a class. I'll use the plus sign here on the right hand side and check off the legend box to improve the legibility of our graph so we know which color represents which class. On the x-axis here, Excel has automatically used a 1 to label our x-axis. This honestly isn't necessary and just adds extra confusion and clutter to our graph and just doesn't make sense. So let's highlight it there and then just press delete because we don't need it. The last change we'll make is to our y-axis, and you can see the upper bound we have here is 120. Again, this doesn't make a lot of sense because it's impossible to score higher than a 100 on an exam. So let's change that upper bound of 120 to 100. To do this, we will right-click on our y-axis values here and go to the Format Axis option. On the right-hand side over here, we'll select the maximum box and change it to 100 instead of 120. All right, so that looks a lot better. If we take a moment and just look at our graph, you can see that actually no one out of all 3 exams got lower than a 50. And as a result, the graph has a lot of empty white space here in kind of the bottom portion of our graph. It's important to remember kind of the rule of thumb that you always need to start your graph at 0 for most types of charts, like a column, bar, or line chart. But sometimes there are cases, like in this case today, that you can start a chart with a non-zero value. And what this will do is just improve the legibility of our graph a bit and doesn't distort the data relationship at all. So instead of starting at 0, we're actually going to change our lower bound to 40 so that the boxes are just easier to read. So to do this again, we'll click on our y-axis labels and go to the Format Axis option. And then minimum instead of 0 will be 40 this time. All right, so you can see again, it's just easier to read. Think of it almost as we've kind of zoomed in to the top portion of the graph. So now that we have the graph made, let's go over how to read and interpret and what a box plot actually tells us. So let's just take a second to go over the meaning of a box plot. Sometimes box plots are also referred to as box and whiskers plots, but it's just important to remember that a box plot will display data distribution. I'm going to give you guys just a quick couple seconds here to take a look at this example box plot that we have with all the elements labeled. All right, so you can see that the 2 vertical lines here represent the top 25 and the bottom 25% of scores. The box in the middle represents the middle 50%. The upper bound represents the highest, and the lower bound represents the lowest score. And that faint line in the middle of our box here represents the median. So now that we know how to read a box plot chart, if we look back at the one we made just a couple moments ago, you can see that students in general scored much higher on the ELA exam than the science and math one. So I'm sure some of you might be wondering, what would happen to our box plot if our data set contained some very low exam scores? So let's try playing around with this to see what happens. On the left-hand side, I have a copy of the data set that we've been working with in this video, and then I also have a copy of the box plot we just made, but the biggest difference here is that we didn't change the lower bound to 40. We just kept it at 0 this time. So what I'm actually going to do is just delete this first row of exam scores and change the cells or values to just some random lower numbers. And I'm actually going to bold them and make them a different color just so that they stand out to you guys a bit more. All right, so if we look at our box plot, instead of extending the whisker, which is the vertical line, and the lower bound, Excel has just added dots onto our box plot. These dots represent outliers, which are scores that are outside of the normal score range. I'm sure most of you have taken a statistics class at some point, so you probably are familiar with outliers, and you might even know how to calculate them. We're not going to focus on that too much in this video though. I just wanted to show you guys what would happen if we added some lower exam scores onto our box plot. Now you might remember from lesson 8 where we went over the histogram chart. Histograms and box plots are both different types of distribution charts. So let's look at the 3 exam scores in a histogram chart. Alright, so I already have the 3 histograms created here. One for the science exam scores, the second one is for the ELA exam scores, and the third is for the math exam score. If you guys are interested at all in learning how to create these histograms or just learning about histograms in greater detail, please watch lesson 8. I also have a copy of our box plot that we made in the beginning of the video today, using the same data set on the right hand side here. And if we look at the histograms on the left hand side and the box plot on the right hand side, which type of chart do you guys think is more informative? If you said the histogram, so the type of chart on the left hand side, you're correct. If we look at the box plot, it's impossible to see the size of the data set. We can't actually tell how many students wrote these 3 exams. It could be 30, it could be 3,000. We don't know. But if we look at the histogram, you can actually see the number of records for each score range, which means that you can roughly calculate the total number of records. Again on the box plot, and I'm going to zoom in just a bit so we can see it better, you can see that the science and math exam score distributions are very similar. But if we look at the science exam box here, which is the blue, we can see that science exam has a larger box, which means that there are more data points in the middle 50%. But other than that, we can't really get any other detailed data distribution information from the box plot. If we look at the histograms though, we can clearly see the frequency for each score range. Since the science exam and the math exam have similar data distributions, let's do a more detailed comparison of their histograms. Alright, so I just have the 2 histograms here, one for the science exam scores and one for the math exam scores, so we can do a more detailed comparison between the 2 to find out some more information. But first, I also have some summary statistics below my data set here, and these statistics just confirm that the math and science exam scores were very similar to one another. So if we go back up to the histograms here, and we zoom out a bit just so we can see them better, which exam do you guys see from the graph was harder? You can see it was the science exam here because we only had one student who scored greater than a 90%. Which exam was better designed? If we look at the math exam, the histogram follows a more normal distribution compared to the science exam. So you can see that the box plot is not very informative and the histogram is better. Let's go over another type of distribution chart that is more informative and again better than the box plot. Alright, so the last type of chart we're going to look at today is called a swarm plot, which is made using Python. We'll make a video later on how to create a swarm plot chart, but today we're just going to introduce it. These 3 swarm plots in front of us represent the Titanic passenger survival rate, where each gray dot represents a passenger who died and each blue dot represents a passenger who survived. When we take a look at these three swarm plots, you immediately get a very clear picture of the survival rate of the Titanic. But if we look at the box plot of the same data set here, you can see that that clear picture of the survival rate no longer stands out. Honestly, when I look at all these box plots, I don't even want to try to understand them. They are very difficult to read. So that concludes our lesson for today. Overall, we learned how to create box plots, we understood the meaning of a box plot, and we learned about the limitations of the box plot. Statisticians and data scientists use box plots a lot, but for regular users and readers, they are just not informative enough. So personally, I prefer not to use box plots in most cases. See you in next lesson where we will learn how to create map charts. Thank you.